Hi! Okay, so this is my IBM PS2 Model 76, and this is kind of my workhorse 486 that I use for a lot of retro stuff. And right now, the only method I have of transferring files over to it is with a floppy disk, which is kind of a pain. So I'm going to be diving in today to the world of DOS networking and finding out different ways of transferring files from your main PC to your retro PC. By the way, this is what my work area looks like. My little retro lab. So I've got the retro test bench on the left, and I have a newer, just HP Office PC on the right. So I can look stuff up on Vogons or RetroWeb, or download files from Ardent Tool. And what I want to be able to do is I want to be able to transfer files between the two. So here's what I'm going to do. I'm going to make a separate network just for my test bench. And it's going to be physically separated from my home network because old computers have unpatched security vulnerabilities. So I'm isolating them from the internet and the rest of my devices. In this setup, my lab PC is going to be sort of the man in the middle of those two networks. So the networks themselves are disconnected, but the lab PC has two network cards and thus is a member of both networks. So I can use my lab PC to grab files from my server or my NAS and serve them to my retro computers, but the retro computers themselves are isolated from the internet and the rest of my devices. So here's what I need to do to make it work. Number one, I need to install a network card in my PS2. Number two, I need to install a packet driver for that network card so DOS programs can make use of it. Number three, I need to get some network cables and a switch to actually physically connect my retro computer to my lab PC. Number four is I actually need to configure my network settings on both PCs so they both can talk to each other on that network. And once that's done, then I can actually transfer files between the two. Okay, so here's a network card I got. This is a Cabletron E3010. So it's got a RJ45 port in the back and an AUI port. And while we're at it, let's talk a bit about how to install MCA expansion cards, because I don't think I've covered this in depth before. So one of the big features, the big selling points of the microchannel architecture was that it could configure your devices for you, so you wouldn't have to worry about your I/O ports and your IRQ and DMA settings for all your expansion cards, which was a big headache for a lot of people at the time. You can think of it as a very early version of plug and play. But how did the computer know how to configure the device? How did it know what I/O or IRQ or DMA settings that it could use? And the answer is it doesn't. So what would happen is, back in the day, when you bought an MCA expansion card, they would give you something called an option diskette. And the option diskette has a special file on it called an adapter definition file, which contains all the possible settings that the card can use. And what you were supposed to do was boot off your reference diskette and use it to copy this adapter definition file to your reference diskette, so the computer's BIOS can recognize the card and know how to configure it. Then you would shut down, you would install the card, and then you would boot off the reference disk again, and the computer would be able to find the card and configure it. And that's how you install an MCA card. Yay! Now, if you don't own a PS2, and chances are you don't, none of that's going to apply to you. You're probably going to be using an ISA or a PCI network card instead, which is fine, but the methods of configuring the card are going to be different. You might have to change a few jumpers or change a few settings in the BIOS, perhaps. There's probably a lot of good videos on YouTube you can reference, or you can look at the documentation from the manufacturer if you can find it. Anyways, I forgot about the whole copying the option diskette thing, so I just installed a card right away. which really isn't a big deal. It doesn't matter what tool you use to copy the file to the disk. All that matters is the ADF file is on the reference disk so that the computer will recognize it. I got this card on eBay for a very good price, and it didn't come with an option diskette. They almost never do. But that's okay, I was able to find the ADF files and the packet drivers, as a matter of fact, on the Ardent Tool of Capitalism, so should be good to go. And I've got a 165, which means I have a card in there that's not configured. So as expected, when I boot the computer up, I get a 165 error, and that's telling me that I have a new card installed that hasn't been configured yet. So if I press yes to automatically configure the system, it's going to try and configure the card, but it's not going to be able to because it doesn't have the adapter definition file yet. So you have an opportunity here as well to copy the reference diskette. So I have another disk with the ADF on it, and I'm going to pop it in and hit enter. Of course, I could have just copied the ADF file onto the reference diskette itself on another computer and avoided this error entirely. But I guess this serves as a good example of the many ways you can do this. Okay, notice the one beep. That means no errors. You see no error codes on the screen. And I'm going to go back into the reference disk for a minute. This is the main menu. So if you actually had an option disk with your adapter, this is where you would have gone to copy the file to it. But let's have a look at the configuration here. Okay, there's my XJ video card, and this is the one I just installed. It tells me the I/O address, the memory location, and it's on IRQ9. Okay, so I'm booted back up into DOS, and the MCA bus now knows about my new network card, but DOS does not, because remember, DOS is ancient and has no built-in networking support. So you need something called a packet driver. So on the same page on the Ardent Tool website where I found the ADF files, they also had a packet driver for it, and I put it on this disk also. I'm gonna go install. Okay, I'm just gonna speed run the install here because there's nothing terribly interesting in the installer program. The last time I had to do this, it was just an exe file that you had to copy to your local hard drive and put in your auto exec bat. But there's nothing really networking related in here. It's mostly just setting up, telling it the interrupt or the slot number for the card. So you can slow the video down if you want to see it, but like I said, it's not too terribly interesting. I think I ended up going with the default option for most of these settings, and that was fine. Interestingly, despite how many prompts and settings the installation had, it doesn't actually put itself in your auto exec bat for you. It generates a batch file, which you're supposed to put in your auto exec bat, and all it does is call the program itself. So I just modified my auto exec to call that program instead of calling the batch file. And that's pretty much it for the packet driver. There's not really a lot to it besides, installing the program. So I think we'll call this section finished and we'll move on. Okay, let's get it cabled up here. Plug her in. Okay, so this part of the video didn't turn out so well, so sorry for the potato video quality. I guess I was too lazy to set up a smaller tripod under my desk. But I'm just plugging everything in here. So I got a little old 10100 switch, and I'm plugging in my PS2 and my lab PC to it. And yeah, not much to see here. So this is my lab computer. It's just it's even telling me I don't have an IP yet. Before we dive into configuring the network settings, I want to do a really basic networking crash course so you know what we're doing here, because I don't want to take it for granted that everyone watching this video is familiar with the essentials of networking. So a basic home network would probably look something like this, where you have sort of an all-in-one device from your internet service provider, and it functions as your modem, your router, a Wi-Fi access point, and often a switch. So you can, for example, run a cable to one of your computers, or you can wirelessly connect a laptop or a smartphone with just the network name and a password. And it just works. You don't have to configure anything at all. You connect and you have internet access, you have access to the other devices on the network, and you don't have to worry about that stuff. And that's because the all-in-one device from your ISP is doing that for you behind the scenes. But remember that I said we were making a separate network to isolate our retro devices from the internet and from my other devices. And we don't have one of those fancy boxes to provide us with those luxuries. So we're going to have to configure them manually ourselves. So what is it that your little home box provides for you? What are these settings that we have to configure? Well, at minimum, it's going to provide you with an IP address, a subnet mask, a default gateway, and a DNS server. So let's briefly go through these, starting with the IP address. So you could think of an IP address as a unique address that your computer needs to communicate on a network. It's a 32-bit value that specifies 1, what network you're on, and 2, what your address is on said network. So how do we know which part of the IP address specifies the network and which part specifies your individual computer? Well, that's where the subnet mask comes in. The subnet mask tells us how to divvy up our IP address so it knows which part is the network and which part is the individual computer. The default gateway is the IP address of the device that connects your small network to a larger, wider network. Usually this is going to be the IP address of the multifunction device that your ISP gives you, because it connects your home network to the internet. And lastly is the IP address of your DNS server. You could think of DNS as the phone book of the internet. Like I said, every machine on a network needs an IP address to communicate. Well, Google.com or YouTube.com, for example, is not an IP address. So the DNS server is the server that your computer is going to ask, what is the IP address of Google, or what is the IP address of YouTube? The DNS server returns that IP address, so your computer knows how to reach Google or Facebook, for example. That's what your home router is giving you when you connect to it. And it does all this by something called the Dynamic Host Configuration Protocol. And DHCP works on a lease system. So when you get an IP address, you have a lease for a certain period of time, after which it'll have to be reassigned. And you may not always get the same one. But we can also assign these statically, so we can give every individual device their own IP address to keep. And that's what I'm going to do. You could set up your own DHCP and DNS server on this isolated network, but I honestly don't feel the need to. So what IP address do we give our computers? Well, it's my network, so I can just pick one. So I'm going to go with 192.168.70.10 for my lab PC and 192.168.70.11 for my PS2. My subnet mask, I'm going to make 255.255.255.0, which means that the address of my network is going to be 192.168.70, and the address of my computers are going to be 10 and 11. And I picked these settings because 192.168.something.something is an IP address range that's been specifically reserved for private networks. The .70 I just picked randomly, and 255.255.255 divvies it up in a way where the last byte, the last group of digits, you could say, is the address of the computer on the network, which just makes things easier. Now, this network doesn't have a default gateway because it's isolated. There's no way in or out of it. The computers can only talk amongst themselves, so I'm going to leave it blank. Same goes for the DNS server. This network's not going to be connected to the internet, and I'm not going to be referring to the computers on a network by host name, just by the IP address, so I don't need one. Okay, that's enough network talk for now. If I go into more details, this video will be an hour long, so let's get these machines configured. So I'm on my lab PC now. As you can see, I'm running MX Linux on this one. And you could configure this on the terminal if you're hardcore, but I'm just going to go into my system settings here, and I'm going to go into my network connections. And in my IP4 settings, I'm going to change the method to manual because I want to set the IP address manually. And I'm going to click add on here to add an IP address. I'm going to type in the address that I want to give it, 192.168.70.10. I'm going to use 255.255.255.0 for the subnet mask. And like we discussed, I'm going to leave the DNS servers and the gateway blank. And I'm going to click apply, and then I'm going to activate the connection. And just a little bit of an addendum here, because I know most of you guys are using Windows, so I'm just going to go into my control panel. And I'm looking for Network and Sharing Center. And I'm going to go to Change Adapter Settings and find my Ethernet adapter. I'm going to go to Properties on that. And then I'm going to select IP4 and Properties, and this is where I can put in the static IP. And again, that's going to be 192.168.70, and I'm going to use .12 for this laptop. And subnet mask is just going to be 255.255.255.0, and the rest is blank, and that's it. And that's also it for the configuration. Sort of. Notice I didn't say anything yet about configuring the DOS PC, and that's because, remember, DOS has no native networking support. So whatever configuration you do depends on the application. So let's start with an application called MTCP, which is an open source suite of networking tools with its own TCP/IP stack. And configuration for MTCP is done with a config file. So I made one called mtcp.cfg. There's also a sample config file that comes with it where you can change the values in it to the ones you need. But I only need a few, so I just created a new one. And you can find the relevant settings in the instructions PDF that comes with the software. I'm just setting up the interrupt for my packet driver. The host name I don't really need, but I set it anyway. The IP address is going to be 192.168.70.11, and netmask is 255.255.255.0. You also need to set up an environment variable called mtcp/cfg in DOS and point it at the config file I just made. I recommend putting it in your autoexec.bat so it gets configured every time you start the computer. And after a reboot, you're ready to get started. So it comes with some pretty neat stuff to play with. You get a telnet client. It even comes with a web server. But what I'm interested in is the FTP functionality. So initially I tried to set up the Windows PC as the FTP server. I'm using FileZilla server here, but I just could not get it to work. You can see I'm using ping here to verify that I have connectivity to the FTP server. Nice. And I did have to disable Windows Firewall to get it to work. But whenever I tried to actually run the FTP client, it would just hang and lock up the computer.
I can't type anything.
I was able to use the DOS PC as the FTP server though, and connect to it with the FileZilla client on my lab PC. And getting that to work required editing another configuration file called ftppass.txt. And this is where you set up the user accounts for your FTP server and the locations that they have permission to access. And just for testing, I just left the accounts as they were. I didn't make any new ones. I just used the first account, the one that says Brutman, and I put the sandbox directory to none and the upload directory to any so I could have wide open permissions. You also have to add a line into your main MTCP configuration file to point it to the FTP password file. And I'm just looking at the sample configuration here just to see what it is. And there it is. So I have to put that into my MTCP config.
CFG. Oh, is it SRV? That's why. Okay, so I think I got it. I just commented out this read-only user here. This drive doesn't exist, so if I go FTP serve, and there we go, I should have a server running now. So if I try to make a connection, so I'm back on my lab PC again. This time I'm using the FileZilla client software, and I'm making a connection to the FTP server I just spun up, and I'm gonna try to transfer a file to it. And it might as well be the MS-DOS text editor. I know I'm kind of an IBM guy, but Microsoft's DOS text editor is just so much better than the one that comes with PC-DOS. So I'll make a new folder on my DOS PC. I'm just gonna call it Files. And I've got a copy of it right here, and I'm gonna drag it over. And hey, look at that, I can see it transferring. There we go. It works. So there's one more thing I want to try with MTCP. There's a program called NetDrive, which allows you to make an image file on your modern PC and map a logical drive to it on your retro PC. And to do this, I have to add a device driver in my config.sys called netdrive.sys and reboot. And now I'm setting up the server side on my lab PC. I assumed I would have to compile this from source, but they just give you the binary and it seems to work. So I'm running the NetDrive program with the arguments create, floppy, and 160 to specify a 160 megabyte image. And then I'm just giving it a file name. In the local directory, I went with floppy.vhd. And then I ran netdrive serve to start the server. And it looks like it's working. Couple notes here. I did have to change a few things to get a connection. First, I had to set my MTU in my NTCP configuration file to 1500, which is a fairly standard value. I don't know why they set it so low by default. I also found that I had to disable my firewall on the Linux computer to get a connection on port 2002. I could have just made a rule to allow it, but honestly, I'm just trying to get things working right now. After that, I was able to get a connection, and it did show up on the lab PC as well. But on the DOS PC, it would always crash and give me this divide overflow. NetDrive didn't respond to any input, it just would say divide overflow. And I messed with it for a few hours and I just couldn't get it to work, so your mileage may vary. wow.
Speaking of mileage may vary, Microsoft Network Client for MS-DOS. So this is a program that was actually used back in the day to allow DOS to access Windows file shares. But it doesn't have drivers for my specific card. Only those two Cabletron cards are supported, so I'm guessing even back in the day, MCA network cards weren't widely used or well supported. There is an option to supply your own driver, and from what I've read, this is a different driver from the packet driver. It's something called an NDIS driver, which the card does have.
Really?
But for some reason it wouldn't accept it. So again, I just was not able to get this method to work. But if you have a network card that is supported, I've heard people have had pretty good results with this. I may have to make a follow-up video if I can get this method working. And that brings me to my last method, which did end up working. This is a open source program called EtherDFS, and I've used this before with success, but it is kind of a pain to set up, and it is Linux only. I don't think this works in Windows. Depending on which distribution of Linux you're running, you may have to compile this from source if you download the code from the website or GitHub. But if you're running a Debian-based distro like I am, there's an apt package for it called EtherDFS-server. And what it does is it can take a partition on your modern Linux PC and map it as a network drive to the DOS PC. So the first task at hand is to create that partition, which is pretty easy if you have unallocated space on your drive, or you want to put it on a USB drive or something. If you have a swap partition, you can unmount the swap partition and borrow a few hundred megabytes from that. If you're using LVM, it's pretty straightforward to resize an existing drive. Unfortunately, none of that's true in my case. I assign pretty much the whole hard drive to one partition where the root directory is mounted, so I can't resize it while the operating system's running. So what I ended up doing was booting off a Linux live USB image, and then I could resize my primary partition. So I chose to shrink it down by about 1 gigabyte, and that should be plenty to work with. And I created a new FAT16 partition in the unallocated space. I tried it with FAT32 as well, but I couldn't get that to work. But FAT16 seems to work just fine. And I called mine DOS part for DOS partition, and I click on OK. And now I'm going to click on Apply to apply the changes to the drive. Hopefully this doesn't completely screw my computer, but let's see. Well, that looks pretty ominous, but it looks like the partition operation did complete successfully, so let's reboot and cross our fingers. And success, we're booted back into MX Linux, and I can see my DOS partition there. And if you know Linux, you know that there's no such thing as drive letters. There's only one file system, and to use a different partition, you have to mount it to a folder somewhere. So let's make one, and I put it under /mnt, which is usually where your mounted folders go. And I'm gonna put an entry in my fstab file as well, so it'll mount automatically when I boot into Linux. And I think it's this part more than any other that gave me trouble. Getting a DOS FAT partition to mount on a Linux machine is not exactly straightforward. And you can see here that I was able to mount the folder, but I wasn't able to read or write anything to it. I was just getting permission denied errors. And I ended up spending a couple hours playing with different settings for mounting the drive. And here you can see I can CD into the folder, but I can't actually create a file, so I think I can read but not write. I'm still getting that permission denied error. I did eventually get writes working using this command here to mount the drive. I'll come back to this later and talk a little bit more about it, but for now I'm just going to put it in my FS tab just to save those mounting options. But now I should be at least ready to start the EtherDFS server. So using this command, I found that Aptitude put the EtherDFS binary in /usr/sbin, and if I run it with no arguments, it tells me the proper command line usage. So I'm going to run etherserv-linux, and I'm going to specify my wired connection interface, which is eth0. And if you don't know what yours is, you can use the command ifconfig to find out. And now I'm going to specify the root path, which is the DOS partition I created and mounted to /mnt/DOS. And of course, I'm going to forget to run it as root like I always do. And there we go. EtherDFS server is now running, and it's telling me that it has mapped my DOS partition to drive C. Back on the DOS machine, I've copied the EtherDFS DOS client from the website to a floppy disk, and I'm gonna copy all the files to a folder on my hard drive. By the way, when I said that a machine needs an IP address to communicate on the network, that was sort of a lie.
So a machine needs an IP address to communicate across different networks, but on the same network, you only need what's called a MAC address, and this is what EtherDFS uses. So every network interface, including Wi-Fi ones, have a MAC address hard-coded into them, so you don't have to configure it. So what EtherDFS needs to know is the MAC address of my server and what drive in DOS to map the server drive to. And initially when I tried to run the EtherDFS client, it told me it was unable to map the drive. Then I took its advice and added the line last drive equals Z to my config.sys. And that did the trick. So after rebooting, I tried it again, and this time I'm getting a different error. Note that when you put a blank MAC address in, just the 2 colons, EtherDFS is going to search the network for a server, and in this case it didn't find one, so I had to put in the MAC address of my server explicitly. And if you remember how the server said it mapped drive C to my partition, the C-F indicates that I'm mapping that partition to drive F on my DOS PC. And look at that. It looks like it's ready to go.
So if I go to F drive now, I should see.
Unfortunately, it doesn't seem to work. Yet. It looks like it did find the server, but I can't really do anything on it. All it's given me is the file not found error. And my problem ended up being my mount options in my FS tab. See, the FAT file systems have no concept of permissions. So I think what's happening is that when the client on the DOS side is trying to request a file, the Linux server is saying no, because I don't have permissions for it. So the way around it was to add the UID equals 1000 and GID equals 1000 lines. 1000 being my user ID and my group ID respectively in Linux. And that tells Linux that I have permissions on the whole file system on that partition, basically. And the UMask part tells Linux what my default permissions are. In this case, having it set to 000 makes them just wide open. For the fmask, I don't even think it's necessary, but I have it in there and it works, so I'm not going to screw with it. If you want more information, you can Google for it, or you can look at the man pages for Mount and FS tab. Otherwise, if you don't care, you can just copy my settings.
And go C to F. Hey.
Once I saved my FS tab and remounted the drive, I was able to access the files on the DOS PC.
I see files.
And I was able to confirm I can both read and write. And there we go. And that's going to be about it for this video. Shame I couldn't get the Microsoft client working, but this video is already long enough. And anyway, I think I found my preferred method of sharing files with my DOS computers. This has an advantage over MTCP that you can actively edit files on both computers. So if I make a change on one computer, I don't have to go and FTP it over to the other one again. I can see the changes that I made instantly. And that'll do it for this one. So thanks for following me down the DOS networking rabbit hole. Hope you're not too bored or burnt out by networking. I know I am. Yeah, I'm gonna go and work on something else. Bye.